Alright guys, I'm back. This one, I'm going to put this in with the Stromberg Carlson restoration series, so it'll be part 3, but depending on how much time I've got, may not talk a whole lot about the restoration itself. This video is intended to answer some questions that I had. So first of all, I want to make a correction on the last video, and that is when I talked about the Dremel tool and the cutoff wheels, I made mention that I found out about the new type of cutoff wheels and stuff from Bob over at B. Anderson TV, watching his videos, and I said that it was on when he was doing work on his gray bar TRF radio. The gray bar is my radio. The radio I should have said was the Brunswick 5KR radio. And if you actually want to watch that, there's 15 videos in the series on the 5KR that he has a playlist on. So if you just do a search of B. Anderson TV on YouTube, you'll find him. And you can go to his channel. Then when you go to it, along there's some listings of things you can go to. Starts out with home, then videos, then the next one's playlist. Click on it, and you'll find in the playlist the Brunswick 5KR. So anyway, I wanted to correct that. Now, on one of the questions was asking about the different holes that I was talking about the last time at the first video. You know, like these holes here and stuff. And someone asked me about that, if that could be, you know, kind of a hybrid situation for UHF. Well, for one thing, no, it's not. That was actually for a radio on one of the models. I don't have the SAMs on it. If I did, I'd show a picture of it. But if you on a lot of these that did have and not much newer than this, the UHF would sit right here, tuner, and it's basically a self-contained tuner, just like the VHF is. And there's a cutout right here. And in fact, actually, if you want to see that cutout, again, go back to Bob or B. Anderson TV, and in that playlist you'll see a Stromberg Carlson 21 model 21 TQ. There's like 6 videos on it. The first couple videos, at least the first one or the second one, anyway, you can see the cutout in the chassis where the UHF would go, and he talks about a little bit and stuff and all and that. Now, on at least some of the Stromberg Carlsons, what they did was a double conversion. There's 2 ways of actually hooking up a UHF. The tuner itself could be just fully contained, where the signal feeds through just like a VHF. It feeds in from the antenna, feeds through, gets amplified a little bit. But the primary thing is, in the UHF, what they do is they have a conversion go on there, and that converts down to the IF chain, whatever IF frequency it's centered on. Some of the Stromberg Carlsons, and maybe all of them, I'm not sure, but at least some of the earlier ones, the UHF actually fed into the VHF tuner. A VHF tuner, when you flipped it over to UHF, was actually on channel 1, and what the old channel 1 frequency was. So the UHF tuner took it, converted it from UHF frequencies, whatever channel, down to channel 1 VHF, and then that in turn amplified and converted it down to the IF chain. But some TVs it's just standalone. But either way, you just plug the UHF tuner in, hook up a few wires, and it's good to go. You know, there's some, on the early ones, they did usually like a dial string or something that went to the fine tuning knob. There'd be a pulley on it and stuff. But, so, yeah, that has nothing to do with the cutouts over here. So I hope I answered that. Let's see, what else? Oh, the color of the chassis is not cadmium plating. Cadmium plating will either be, if it has not had any type of oxidation to it, which generally you will find that it has oxidized a little bit, but once you clean the oxidation off, it can actually polish up to almost looking chrome. And when it was brand new, the set was brand new, that's what it did look like it was chrome plated almost. Generally, what you find when you see one of these old TVs or radios that are cadmium plated, there'll either be one or two colors. There'll either be kind of like a white dusting on there, that's cadmium oxide. The other one is yellow, where there's some, where the set was around some sulfur in the atmosphere, so it's cadmium sulfide. Either one of the two, that powder is very toxic, so if you touch it, get it on your fingers, wash your hands really well. But it comes off real easy, it just cleans right off, and then you can either leave it just clean or you can actually polish it. But it will not have a yellow tinge to it. This is zinc chromate plating, is what this is. It was another way of doing things. Just zinc chromium is what it really is. And under its natural state, it's kind of yellow and color, although you can actually polish the zinc yellow away and get the chrome to show, but it will resort back to the yellow within time, depending on humidity or anything. The nice thing about this stuff is this is what it does. If you can see my reflection here, it stays that way. There's zinc and zinc chromate doesn't oxidize very easily, so it'll stay this nice shiny color. So now, and the next question was about the tuner itself, and mainly the fine tuning. So I kind of simply put the tuner back together. I still got to replace some resistors in it, so I don't have it completely together. But if you use, well, there'd be a screw here, but other than that, if you looked at the front of the tuner without it being dismantled, this is what you would see. This is your, of course it's going to move around a little bit, I don't have the screw in there, but this is your fine tuning. Now what that's doing, and I can zoom in just a little bit. There we go. What that's doing is varying in capacitance. Now the way that works is you can't really see it, but this here is one plate of the capacitor. It goes to ground. That's what the fine tuning does. It's a variable capacitor that goes to ground, and I'll show that in the schematic in a minute. You take that off. Now you see this cam phenolic. If I rotate it, you see this. This is a piece of, there's a metal button in there that is insulated, I think in this case with ceramic, some or other type of materials. But that goes to a wire which comes right through here and right down to here. The other end of that is just soldered to a button right here. Now, what's going on is I rotate it. Now this is the minimum amount of capacitance. At that point, it's basically an air capacitor, air dielectric capacitor. It's just air between this plate and that plate. Dielectric for air is 1, the constant is. Now, if you rotate this, you notice it starts covering more and more of that metal. And this is an insulator. It's bakelite, basically. It's phenolic on each side with some wood filler, pulp fillers inside. But as you go, more and more of it's introduced in. That is changing the dielectric of this capacitor, the dielectric constant. You know, at about halfway, I've got about half air, half of this phenolic. Not sure what it is because it depends on the material that's in the center. Whoop, I dropped off the other piece. That's in the center here. And that varies with different manufacturers, so there's no actual set of what that is. But in any case, the constant's going to be somewhere in between the two. Once I get clear to one end, and there's stops on this, you see these little metal tabs, and that hits that point there, which stops it from turning. It's fully engaged pretty much, completely covering, so that's the maximum capacitance. As you introduce a higher dielectric constant into between two plates that had a lower one, such as air, you increase the capacitance, because capacitance is the function of the area of the plate, usually just one plate, but the area of the plate, the distance separation between the plates, so how far is it between here and the next plate, and the dielectric constant, whatever that is. Different materials, different things have different dielectric constants, and so if I increase the distance between the plates, the capacitance goes down. If I increase the area of the plate, the capacitance goes up. If I decrease the distance, I hope I said that right in the first place. If I increase the distance, the capacitance goes down. Decrease the distance, put them closer together, it goes up. If I increase the plate area, I have more capacitance. If I decrease the plate area, I have smaller capacitance. And if I increase my dielectric constant, I increase the capacitance. If I decreased it, I decrease the capacitance. So basically what we're doing with this, we're taking it from some number on the dielectric constant when it's at max capacitance, where this is fully engaged. And as we rotate it, it's cammed down. So more and more of it's taken away, and more less of this dielectric constant. Gets halfway, it's about somewhere between 1 and whatever that is. And you keep going until you hit the other stop, and it's completely unengaged from the capacitor. We only have air in there, so that's our lowest capacitance. And of course this just sits on, there's a spring loaded here just to keep this pushed up against the little nubbin here and stuff, but that's really all there is to it. Most TVs use this form. I think there is one tuner manufacturer out there back in the day that did use variable inductance for fine tuning, but 90% or more use some form of variable capacitance. A lot of them kind of similar to this, but some of them, it was different designs on how it done. Some they had a plate that moved in and out of another set of plate, an outside plate, and would come in like a cylinder. Like if this is one plate and the other plate would slide in and out. And they basically just used a device that had a cam on it, spring loaded. They hit an arm that then went to a lever that would move that back and forth. But it gives, the whole idea of this, it just gives better control. Your course adjustment, of course, is your channel selector. You tune in switches like channel 3, and then your fine adjustment will be this. You have a lot more control with this to just do that little fine tuning. This is a relatively low capacitance, somewhere between, at the lowest point, probably around 0.5 picofarads to, well, maybe 9 or 10 at the maximum. Now where it's located, when you look at the schematic, is right here. And as you can see, it says fine tuning. One side goes all the way over here to the coil. That's that wire. Another lead will lead off, which it does have, to the plate of the 6J6, the oscillator section of it. And we're just varying the capacitance in the circuit, basically through the tube and across this coil. And the coil, for alignment procedure, when you're doing alignment, it has a slug in it that you adjust when you're doing alignment. But that's your fine tuning. And that's all there is to it. So I think that's probably about it. Oh, one other thing I wanted to talk about. I talked a little bit about more and more the domino style micas, or the sealed micas, like this guy right here, and that one down there, and so forth. That I went ahead and bought replacements for them, even though I haven't tested them yet. But I'm seeing more in the forums and on videos, and people starting to show, seeing some signs of these. And not to the point yet that, like I said last time, that you need to worry about maybe shotgunning these, as well as the, the other, the paper caps. But at least enough that maybe it might warrant, pull them out of the circuit, just one lead. That's all you got to do. And, testing them for leakage and capacitance. So, anyway, basically, some people are finding certain brands that they think is bad. That's just something that's just happening on a particular chassis that they're working on. As far as brand goes and everything, one person might find a particular brand and maybe a TV or a radio that they're working on, it seems those brands are leaky. Maybe another brand in there it isn't. And then another person might find some other brand, completely different situation. There's a lot of variables goes in to these or any other capacitor failure. Climate, usage, a whole bunch of other different scenarios, where the capacitor is actually hooked into the circuit, how much voltage is across it, how much current's going through it. There's many variables that will determine when a cap goes bad or if it will go bad. In fact, if you actually look at, say, a TV or a radio that came out of the desert southwest, humidity quite low, extremely low down there in the desert areas, and if that's where it served all of its life, it was there, you may find that there's, at least as far as the paper caps go and the micas and stuff like that, you may not find any leakage in them. They may seem to be perfectly fine. But remember one thing: you may not you may not live in that area. You may live in an area where the humidity is higher. Even if you have air conditioning, it will be higher. And Now you're going to start applying power to these. You're going to start running the radio or the TV, and between that and the fact your humidity is a little higher, things might start. They will fail in time. How quick, I don't know. Again, many variables. But as far as brand goes, there was no generic back in the day. There was no cheap caps or resistors or anything. They were all on the same level as far as manufacturing and engineering goes. In fact, they were really quite similar in price. One of the biggest reasons why one company might use one and another company use another one. Companies, when what they do, manufacturing does, is they put out bids for their components for a contract that may be from a year to usually no longer than 5 years. First thing they're looking, one thing they're looking for is the lowest price. But also, more importantly, a lot of manufacturers are looking, can you guarantee supply? You're not going to, at some point when I call in another order during this contract period, you're going to tell me that I'm out. It'll be a month before we can fill your order. That doesn't work. So they're looking at two different things there. They may, but the price usually on those bids are pretty darn close to each other. Sometimes they order enough from any particular company, especially the older stuff that you find like in the 30s and early 40s and stuff. Mostly pre-war, but you can find post-war. They can actually get the company that they're going to go with as one other little part is to put a brand name, their badging on it and part number on the the capacitor and stuff. So, but it is, as far as is one brand worse than the other brand? No, not really. As much as you may find a particular brand in your situation, if you're looking actually at brands that is giving you troubles, they're bad and everything, you may run into, the next chassis that you work on, or chassis, it can be different, and so on. So, it varies. Again, there's many variables goes into what happens these. The biggest point I was trying to make is that it's probably getting to the point now, these are getting old enough that they're showing some higher failure rate, no matter what brand they are. And so it may be advantageous to at least spot check some of them. Generally, you don't have that many micas in anything, so you can actually check all of them. Like I said, in this set, there's only 5. So it would probably be to your advantage to actually take the time and disconnect them. I mean, you can go ahead and do the troubleshooting if you want. It's good practice. Leave them in there. And if you have a problem, trace it out, locate the circuit it's in, and then go from there. And what you'll end up doing is you'll probably finalize your diagnosis to the mica that you could have tested beforehand if you wanted to. But they're not at that level yet to warrant just saying, just go ahead and shotgun them. Really. So anyway, I leave that up to you. I just want to point that out. And so as far as the TV goes, I haven't really done much more to it. I haven't had much time, but there is something I want to kind of point out and show here of interest if I can. I don't know if you'll see it, but you see this cap? Okay, it's got a band around it to hold it in place, and we got a terminal strip sitting here. The band comes down and is riveted right here. So is the terminal strip. So I got two things going underneath that one rivet. The terminal strip, which you can't really see, but where I'm rubbing them against, has a where you can connect wires to it. Okay, some of them are there; those don't exist, but this one can, and it's a ground attachment. You can make a ground attachment. It's not attached to it. This resistor and this cap goes to this point here, which is grounded. It's grounded through this wire right here. This goes up and comes around underneath, which is probably hard for you to see, and hooks here. Now why didn't they ground here? Because where this goes is to the basically the same style terminal strip. That's this point here. This piece here comes down and bends and is riveted to the chassis, but only it is riveted. There's only one thing underneath that rivet. Now the reason why they did that, I mean that took some wire and took some time, is because they didn't trust that ground, because they had two different things underneath that rivet. Excuse me. What can happen when you got something like that is it could loosen the rivet. Either one of these, or you may not even get the rivet really tight and really smacked in good or crimped in good. Whereas with just one thing, it's a lot better. So they chose to run a ground wire up there. Same way with this here. The can capacitors snap into place. You know, right here. They snap into this. And these cans, right here, these cans are ground. Alright? You know, they bend over here, and then they got the little piece that with the twist locks on it, metal piece, like this guy. Okay. Well, in this case, they're not twist locked, but they didn't want to rely on this spring-loaded piece. All right. So what they did was they ran this ground wire through some of the holes here. There's one hole and the other one the same way, to guarantee a ground as opposed to relying on the clamp there. So I think that's about all I've got for you. So I hope that answers some of your questions. As far as the rest of comments and stuff, a lot of you guys have been that you're learning and that you're enjoying the videos and everything. Well, thank you for all your kind words. I have mentioned this before, so I'll mention it more for the newbies. I do reply sometimes to short questions or something like that in the comments. Sometimes I'll, you know, just say thanks or thanks for watching or something like that. I have a lot of arthritis in my wrist, and I have yet to find a damn keyboard that doesn't cause any pain. Yeah, you know, basically I can probably do a short sentence before I start getting in trouble. So I don't generally comment on other people's videos a whole heck of a lot. Once in a while I will, and I don't generally answer the videos too much unless, or comments on my videos. Alright guys, sorry about that. I think I left off about talking about answering comments and stuff. I was pretty much done, but I think the last part of the sentence was that I don't generally answer even comments on my own videos. Unless there's a question and I can answer it in short form. The reason why the kind of change here, pause or whatever, is this a digital camera that does video. I opted with it because it actually, for the price, it had more abilities and did a better job than what they had for video cameras. But digital cameras that do video will only do usually a half-hour segment, mainly for heat. And then they shut off, and then you have to restart them, and then you can do another half hour. So anyway, I wasn't paying that close attention to the time. It counts down, and it just shut off. And I'm standing here talking, and I happened to look down at the screen, and it had been shut off. So I had to go through it and find out where I left off at. So I don't have much else to really say on this, and I hope this answered your questions that you had. If you have more, just send them in. I will try to. A lot of you put in there some really nice comments, and thanks for those. And I'm glad that you're enjoying the videos and you're getting something out of them. The next video on this probably won't be until this is Sunday the 5th, and won't be until probably next weekend. This coming week is kind of a busy week, so I probably won't get much done first on the TV, as well as getting a chance to make a video. And on the next video, as I do this TV, I want to also talk a little bit about basic theory, and not getting really in depth in it, but and also signal path and things of this nature. So any of you that end up getting TVs to work on, you'll feel a little more comfortable with them. And it may be of interest to other people. One thing that I will talk about on the next video, if my memory is nice to me and lets me think about it, I remember that I said this. There is 3 transformers that I want to discuss in a little bit about, but I'm going to let you kind of with a little question, if you will, or just something to think about. But those 3 transformers: horizontal output transformer, the vertical output transformer, and the audio output transformer. Now the audio output is transformers on the speaker, so it's not on the set. And of course the subchassis here has got the horizontal output transformer. This here is the vertical output transformer. Basically what we're going to talk about is what they have in common. Those 3 transformers have something in common, and in fact actually it's their primary purpose. Beyond the fact that the horizontal output transformer has the high voltage kickback or flyback circuit on it, that's kind of in a way separate, even though it's built in the same transformer, but it's some separate thing. The actual horizontal output transformer part is what I'm talking about. It has one purpose, same as the vertical transformer, output transformer, as well as audio output transformer. So anyway, you don't have to answer it. If you want to comment an answer to that, that's fine. It's not really a question, but it's just a tease of what I will talk about. And then of course we'll talk about where I'm at as far as how much more I got done and stuff. So anyway, the old ritual, thumbs up if you like the video, and please do comment. I read your comments, that's for darn sure, and I get stuff from them. If you got questions, see it gives me something to answer and make videos on. And if you have a question, a whole bunch of everybody else has the same question. So continue to ask questions. And anyway, thanks for subscribing and watching, and I'll see you guys on the next video.